Hello and welcome to In Simple Terms with Satish. Today we are talking about protected resource metadata for remote AI tools. That sounds technical, but the basic idea is simple. Before an AI client can log into a protected tool, it has to know where the right login system is. Let us start with an everyday example. Imagine you arrive at a large office campus you have never visited before. You know you are supposed to get access to one building inside that campus. But before anybody gives you a badge, you need a clear sign. That sign should tell you where the security desk is, which entrance handles visitors, and what kind of pass you are supposed to ask for. Without that sign, every visitor starts guessing. Some people walk to the wrong building. Some ask the wrong desk. Some use a pass meant for a completely different entrance. Protected resource metadata is that sign for a remote software system. Now let us bring that back to technology. In remote AI tool systems, and especially in remote MCP servers, a tool server may protect access to documents, repositories, databases, or other connected systems. When a client reaches that protected server, the server needs a standard way to say this resource is protected. Here is where you can learn how authorization works for this resource. Here is which authorization server or servers are valid. And here is guidance about what kind of access the current request meets. That is what protected resource metadata does. It gives the client a structured way to discover the trust setup for that specific resource. Why does that matter? Because the alternative is guessing, and guessed security boundaries do not stay clean for very long. A client might use an old hard-coded authorization URL. It might reuse a token that was meant for a different server. It might ask for the wrong scope. Or it might trust any token from the right identity provider, even if that token was never meant for this resource. That is how small auth shortcuts become real system problems. In the latest MCP authorization model, this discovery step is treated as part of the actual protocol. Remote MCP servers are expected to publish protected resource metadata, and clients are expected to use it to find the right authorization server. So this is not just extra documentation, it is part of how a secure client and server find each other. Now here is an important nuance. This discovery layer comes before the choice of auth flow. If a human is using the client, the system may use an interactive login flow. If the client is a background service, it may use client credentials and authenticate as a service identity instead. But in both cases, the client still has to discover the right trust boundary first. That is the deeper idea. The token is not the whole story. The client first has to find the right front desk. Now here is the catch. Because this metadata sounds boring, teams sometimes treat it like plumbing they can wire by hand once and forget. But if the discovery path is wrong, the rest of the auth stack stands on shaky ground. A signed token can still be accepted by the wrong resource. A correct user can still be sent to the wrong authorization server. A scope can still be technically valid but wrong for the tool being called. So the lesson is simple. When you design remote AI tools, do not only ask whether the system uses OAuth. Ask how the client learns where authorization lives for that specific tool server. Ask whether the server clearly points to the right authorization system. Ask whether the token is valid for that exact resource. And ask whether the client can recover cleanly when it needs different scope. In simple terms, protected resource metadata is the front desk sign for remote AI tools. Without it, clients guess. And when security depends on guessing, the design is already weaker than it looks. If this helped you understand the topic in simple terms, follow or subscribe to In Simple Terms with Satish. I will see you in the next episode.